Hi everyone. I'm ready to walk through some examples of figuring out where different angles in radian measure lie and talk a little bit about the co-terminal idea again. This co-terminal thing, again, it's not that we use that so very much later. It just really gets you thinking about how these angles fit in the quadrant system and going both directions. So I think it's super good practice for right now. Okay, so first one is asking us to draw in standard position the angle negative pi over 3. So what I would say always is our starting point, just like with degrees, knowing there's 360 degrees in a rotation. For radians, we know that if we've gone all the way around, so this would be 0, our starting point, it's also 2 pi and negative 2 pi and 4 pi and so on. If we split that in half, any rotation that lands us over here is going to be a pi or a 3 pi or a 5 pi. So let's just focus on one time around now instead of all the extra multiples of 2 pi added on. So a quarter of the way around the circle, this is a pi over 2. So being able to count in pi over 2s is a really nice start. Let me switch to my highlighter. So if we start at 0, rotating a quarter of the way around is 1 pi over 2. This is 2 pi over 2s, which is pi. This is 3 pi over 2s. And then 4 pi over 2s is 2 pi. So down at the bottom, this would be a 3 pi over 2. Okay, so I'm kind of getting distracted from my pi over 3s. What I want to say about pi over 3s is we just want to visualize taking the top or the bottom half of the circle, for example, and splitting it into 3s. So if I remember this right, there's 6. So here, I think we want to go here and here for pi over 3. So if we count our little polar directions, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay, so that's about what a pi over 3 looks like. So it's a little above that 45-degree angle, that halfway mark in the quarter. We're supposed to be going negative pi over 3, so we're going to want to head down instead. So we're going to start off this way and say 1, 2, 3, 4. And this is our ray. And this right here is negative pi over 3 radians. Okay, so if we want to look for coterminal angles, again, there's usually one that's just the opposite direction. I'm not going to make that so big. I'm going to run out of room. We'll follow this around. Okay, so that is a really nice coterminal angle. So the question is, how big is that? And there's different ways to think about it. We know if we went all the way around, we'd have gone 2 pi. So you could say 2 pi, but we haven't done that pi over 3 yet, 2 pi minus pi over 3. And remember that 2 pi is the same as 6 pi over 3s. So this is a 5 pi over 3. And those are our two that are less than 2 pi, less than all the way around the circle. From there, you can do as many as you want just by continuing more around the circle. So if we say, okay, negative 2 pi or negative pi over 3, and then we go another 2 pi to get back to that same location, that's negative pi over 3, and then we went minus another 2 pi. And just like before, I'd say, okay, but 2 pi is 6 pi over 3. So if you aren't great at fractions, you're going to be very soon. So that was negative 7 pi over 3 to get all the way around in an additional pi over 3. If we went further the other direction, so we did one where we went all the way to here, and then we want to go all the way around once more. That one was 5 pi over 3. And then we went another 2 pi, which is 6 pi over 3. So that would be an 11 pi over 3. So this is tricky at first, but we're going to get good at counting off how many pi over 3s, and hopefully we're going to get good at all this fractions of pi stuff. We're going to get really good at fractions with denominators of 2, 3, 4, 6, I would say, by the time we're done with this. Okay, next one, we have 5 pi over 6. So now we want to think of taking our pi, which we know pi is halfway around, so pi would get us out here, and we want to divide it into 6 pieces. So when you're working on the polar grid, I know I don't always have a polar grid for you, but I think I have some good ones in your homework. These are kind of handy for what we're doing right now. You could say I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 of these in a half rotation. So each of those is a pi over 12, which we probably won't use a ton of those, but we do use pi over 6s, which would be 2. So this is a pi over 6. And then another 2 pi over 6s, which is a pi over 3. 3 pi over 6s, which is a pi over 2. 4 pi over 6s, and then 5 pi over 6 right there. Okay, so I'm going to erase my pi and say here I'll just do it right over the top of those. Start and go 5/6 of the way around. That is a 5 pi over 6. Okay, so I'm going to zoom a little so my pen doesn't seem quite so big. Co-terminal angles for that, again, I always like to start right away. Let me put my ray in. And just find the one that I get from going the opposite direction. So if that was 5/6 of the way around, then this other one is 6/6 is halfway, right? 6 pi over 6 is halfway around. And then we need one more. This is a pi over 6 right here. We went 5 pi over 6. There's one more pi over 6 to get down there. So we need pi plus pi over 6. And this is going to be 6 pi over 6 plus pi over 6 is 7 pi over 6. But we went the opposite direction, so it's really a negative 7 pi over 6. So you can either do negatives when you're doing the arithmetic, or you can just add it up and then just try not to forget that if you're going the opposite direction, that's actually a negative angle. Okay, so what else do we have? If we did our 5 pi over 6 and then went all the way around again, so that's a 5 pi over 6 plus 2 pi. 2 pi is 12 pi over 6s. So we get 17 pi over 6s. That's the orange one. And then same thing going the opposite direction. What color haven't I used? We'll do pink. If we go, that was the positive direction. Okay, so if we match our green one, we go 7 pi over 6, and then we go an additional 2 pi. So that's 7 pi over 6, and an additional 2 pi, which is 12 pi over 6s. So we get 19 pi over 6, and once again, remember that that's negative. So negative 19, pi over 6s. That's a little big. Okay, couple more. 17 pi over 4. Okay, so now we want to be able to figure out our pi over 4s. But one thing nice to notice here is 2 pi, if we want to do that in pi over 4s. Okay, so if we multiply top and bottom by 4, is 8 pi over 4. So if we go 8 pi over 4, that's all the way around the circle. If we do another 8 pi over 4, that's 16 pi over 4. That's twice around the circle. So really this is saying go twice around the circle and then one more pi over 4. For pi over 4s, remember a quarter of the way around is a pi over 2. So that's just exactly half of that. So we want this one that goes right down the middle. That's 1, 2, 3 grid lines over. So that is a 17 pi over 4. And basically the way we just figured that out gives us a free coterminal angle, a really easy one. This right here we just said is a pi over 4. So if you just knock out those 2 times around the circle, you get a really good easy coterminal angle right there. If we went the opposite way, we know that all the way around is 8 pi over 4. So if we stop 1 pi over 4 short of that, that's 7 pi over 4s around the circle. Excuse me. Okay. And then let's see, maybe one more. Okay, so what else could we do? we could just go ahead and do one time around the, oh, that's going to get kind of messy. Let's just do another lap around negative. So if we go all the way around, just like we did with green, and then we go one more extra lap in there, getting kind of messy. So that was 7 pi over 4. And then we went one more lap, which is 8 pi over 4. 2 pi is 8 pi over 4. So we get 15 pi over 4, but pay attention to your direction. That was a negative 15 pi over 4. Okay, last one, and this is pretty easy to count, but it's a negative one and it's a big angle, so it's good practice. Pi over 2's, we know that this is a pi over 2, so we just want to be able to kind of count those off. We're going to go the other direction, so we're going to go a pi over 2, 2 pi over 2, 3, 4, 5, 6, 7, 8, 9 pi over 2's, and that was negative. So just like last time, I would say jump right on the fact that that gives you a really easy angle right here. That's just a negative pi over 2. And then that gives you a fairly easy one over here. So all the way around this time is pi over 2's 4 pi over 2's, which means that we've just gone, I guess I don't even need to do that, 1, 2, 3 pi over 2's to get that one. And then what do we have? 2 negative, 1 more positive. So we could just say, okay, what color have I not used? Purple. If we go all the way to here, 3 pi over 2, and then we do one more lap. So that's 4, 5, 6, 7 pi over 2's. That would also be co-terminal. Okay, so hopefully that gives you the idea. I know probably it's kind of a headache hearing all those fractions. I promise you'll get really good at this as we keep going. We're going to do it all quarter long. So practice, practice, and hopefully it'll start to stick. Okay, thanks for watching.